welcome to True Projects. In this video, we are going to explain about the project that is blockchain-enabled federated learning for enhanced collaborative intrusion detection in vehicular edge computing. Before getting into the execution, first let us understand what is the project about. Intelligent Transportation System or ITS. They are really changing how our transportation networks function. They are all about integrating advanced technologies to make things like traffic management and public transport more efficient. For example, traffic lights can now sync with real time conditions, so they adjust automatically to ease congestion. Things like electronic toll collection allows vehicles to pass through tolls without stopping, and we get real time updates for buses and trains, which makes commuting so much easier. This is all made possible through something called vehicle to vehicle everything, that is V2X, where vehicles can directly share data with the other vehicles, traffic systems, or even pedestrians. It is a whole network working together to improve safety, efficiency, and even sustainability. But here the flip side is, since this system relies so much on data exchange, it opens up a lot of security privacy issues. For example, someone could hack into the system and send false traffic updates or disrupt communication between vehicles and signals, which could lead to accidents or system failures. So while IDEAS is a game changer for transportation, addressing these vulnerabilities is crucial to make sure that system is safe and reliable for everyone. And here, one of the biggest challenges in intelligent transportation system or ITS we face is cyber threats. These includes things like zero-day attacks, which are particularly dangerous because they exploit vulnerabilities that haven't even been discovered or patched yet. Now imagine what happens if a hacker gains access to a traffic control system. They could disrupt traffic lights, manipulate signals, or even shut down parts of the system, putting people's safety at serious risk. So the problem gets worse because of many ITS solutions, that is intrusion detection solutions. They rely on traditional machine learning models that are centralized. This means all the data and operations are managed in one place. If that single point is compromised, whether through a cyber attack or a system failure, the entire network goes down. Plus, this centralized systems collect a lot of sensitive data like personal and vehicular information, which raises a privacy issues. So, to tackle these issues, we need innovative solutions. It is not just about securing the data, it is about ensuring that the entire system, how it learns, communicates, and functions, is protected. And with the growing amount of personal and vehicle data being generated every day, it is clear that current systems don't have strong enough mechanisms to handle collaborative learning or secure communication effectively. That is why there is such an important need to develop smarter and more secure approaches to protect ideas from these evolving threats. So, this project is designed to keep smarter transportation networks safe from cyber threats. Now, instead of a traditional approach where all the data is sent to a central place for processing, which could raise privacy issues, we are using a much smarter and safer method by combining two powerful techniques that are federated learning and blockchain technology. So, here is how it works. So, here we will be having two different nodes. So, here we will be having a group of edge nodes that each have their own private data. Instead of sending this data to the cloud or any centralized server, which could be risky, Edge node only trains a model on its own data, so the data is safe and private on that particular node. Once that node has trained its local model, it doesn't send the raw data anywhere. Instead, it just shares the learned knowledge from the model, which are the model weights. So these are the kinds of like instead insights that node has gained from a local data. So this information, this model weights are sent to the blockchain network where all the model weights from different nodes are aggregated. And what is cool about this blockchain is it acts like a secure ledger that keeps track of all these weights from each node. And the blockchain makes sure everything is transparent, verifiable, and tamper proof. After the model weights are combined, the system creates one global model that represents the knowledge from all the nodes. So, this global model is then sent back to each node. So, now they all have the benefit of aggregated knowledge from across the system. So the best part is that even though the model is being updated and improved with the data from all over, the raw data never leaves the nodes. So this way system can detect new and emerging threats by learning from the experiences of all the nodes while keeping everyone's data private and secure. And here, the system not only uses federated learning but also includes a reputation system built on blockchain to make sure that each node in the network is trustworthy. Think of it like grading system for each device or vehicle participating in the learning process. The blockchain ensures that the updates from each node are secure and tamper-proof by using something called hash codes, which are like a digital fingerprints that verify the authenticity of the data. So they all are secured through this hash code. So the data which is stored in the blockchain is secured through this hash code. And moving to the next part, now we train the system. They use for training the system, we use a data set called UNSW NB15, which helps the system to learn, identify different patterns of cyber attacks. This data set is used for both binary classification, deciding if there is any attack or not, and multi-class classification, that is identifying specific type of attack. So binary classification is nothing but we just classify whether there is attack or not. And coming to the multi-class classification, we will be classifying which type of attack it is. So it is the difference between binary and multi-class. So by using this data set, the system performs really well, detecting a wide range of attacks with high accuracy. So not only does this framework improve the security for intelligent transportation system, but it also ensures privacy and trust throughout the network. And because it is decentralized, it is scalable solution that can adapt to future threats without the risk of centralized systems being attacked or compromised. So this is the proposed system of the project. Now moving to the methodology. So to implement this project, we are supposed to follow these steps. So first step involves is uploading the UNSW NB15 dataset. So it is UNSW NB15 dataset which is used for training the models. Once the data is uploaded, the dataset is read by the application so it can be pre-processed and analyzed. The dataset contains network traffic data that includes different types of attacks and normal traffic for both the binary and also multi-class classification. Then the dataset needs to be pre-processed to ensure the data is clean and ready for training. In this step, the application handles missing values if there are any and shuffles the dataset for randomization and normalizes the dataset, that is scaling values to a standard range. The dataset is then split into two sets. One is training set and the testing set where 80% of the training data is 80% of the data is assigned to training and the remaining 20 is for testing. This allows the model to learn from the training data and be evaluated on the test data. Then comes run edge node 1 binary classes. So in this step, edge node 1 will train on a portion of binary dataset. The binary classification task involves predicting whether traffic is normal or attack, so whether there is traffic or not. After training on this subset, node 1 will generate a local binary model. The model learned by this node is based on its local dataset and reflects only the patterns found in the subset. Then comes running edge node 1 multi-class. So this step is similar to the previous one but involves multi-class classification. In this case, node 1 will train on a portion of the multi-class dataset where the task is to classify the traffic into one of the several attack categories. After training, node 1 generates a local multi-class model which will be sent to the blockchain for storage. Then comes running edge node 2 on binary class. So here edge node 2 will train on the remaining part of the binary dataset just like node 1. It will train to classify traffic into normal or attack. After training, each edge node, that is edge node 2, generates its own binary local model which will then be sent to the blockchain for storage. Coming to edge node 2 multiclass. So here edge node 2 will now train the remaining part of the multiclass dataset. It will classify traffic into multiple attack types based on portion of the dataset. Once the model is trained, it generates a local multi-class model which is also sent to the blockchain for storage. Then comes aggregating and running global binary FL models, that is federated learning models. So this module collects the binary local models from both the edge node 1 and edge node 2 which were stored on the blockchain. These models are then aggregated to create a global binary model by combining the knowledge from both the nodes. The global model is applied to the test data to calculate the prediction accuracy, determining how well the model performs on unseen data. Then comes the next part, aggregating run global model for multi-class federated learning models. Similar to binary models, this module collects the multi-class model from both edge node 1 and edge node 2 stored in the blockchain. The models are aggregated into a global multi-class model, and this global model is then applied to the test data to calculate the prediction accuracy, assessing how it identifies various attack types. So in the next step, we compare all the federated learning models that are binary and also multi-class models through the graphs. And then comes the predicting part, where in the final step, in the application, we will be uploading the test data, and the global multi-class federated learning model is then used to predict whether the test data contains any attacks or not. So to implement this project, we need hardware and software requirements. And coming to hardware, we need operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 50 GB and above. And software requirements are Node.js, Python 3.7.0 version, Visual Studio Community version. So this is the overview of the project. Now let us execute. So open the code folder which contains source code files. So let's open the code folder of the project. So these are the source code files in the code folder of the project. Let us understand each of them. How will they be used in this project? So let's open the dataset folder. This is the main dataset used to train the models. So let's open it. It's being loaded. Just wait for a while. So here is the dataset. So these are the different features which impact the attacks. So based on these, we will be detecting the attacks. And here in the last column, last two columns, this is the target. These are the two target classes. So this is the binary target class. This is the multi-class target class. Here, if you observe, here total we have these types of attacks in multi-class. And here, if we apply filter, you can see we have only two classes whether there is attack or not. So excluding this feature, we will be training all the multi-class, and excluding this feature, this column, we will be training all the binary class models. Now let's close this. And here in this file, we have the test data that we will be uploading in the front end. So let's see this one. So these are different input test cases that we will be giving as the input. So close this, get back. And this is the Hello 8 folder. So in this folder, we have node modules. This consists of dependencies or modules needed for this project. Let's open it. And this is .bin folder. This .bin folder often contains executable scripts related to the project dependencies. So open it. Now we need to run blockchain.bat file. So search for that. This is the file. We need to double click on that to start the blockchain. And this script will initiate the local Ethereum blockchain for development purpose. It contains commands to start the blockchain environment. So double click on it. And blockchain will be hosted on the local machine at this local host of the port. So just wait, blockchain will be hosted. So blockchain is hosted at this local host and port. So this is the local host and this is the port. And this address allows us to interact with the blockchain using various tools and applications. Now we need to execute the command truffle space migrate. So give the command truffle space migrate and now click on enter. This will compile and deploy the smart contracts. Truffle is a development framework for Ethereum that simplifies the process of compiling and deploying smart contracts. They are deployed on a blockchain network and they can facilitate various transactions such as transferring tokens or managing digital assets. Once the migration is completed, Truffle will provide us with a unique Ethereum contract address. So this is the unique Ethereum contract address. This address represents the location of the deployed smart contract on the blockchain. And to execute solidity file of solidity code, it handles data structures, to handle the solidity code and compile smart contracts. This is the amount of gas consumed. So this is the amount of gas consumed. So minimize this. So blockchain server is hosted. Now get back. And this is the solidity code. We initially talked solidity code related to gas use, right? So this is the solidity code. This file consists of solidity code and it handles data structures, functions, and events with modifiers for validation. And these are the Python code files that are important for this project. And this is the run.bat file. Instead of executing project through command line interface, we have created this Windows batch file. We have to double click on it to execute the project. So this is the front end of the project, which is built using Tkinter framework. This is the graphical user interface of the project. With this, we can interact with the project. So first, we are supposed to upload the dataset. So click on this upload UNSW NV15 dataset. And here we are supposed to upload this dataset. Select it, click on open, and here the dataset is loaded. So you can observe that dataset is loaded, and these are some samples of the dataset. So these are the top 5 rows. These are the top 5 rows and these are the bottom 5 rows. And these are the column labels. And this is the address of the data set where it is stored. And in the data set, we have total 2390 rows and 41 columns. So this is the overview. Now let's see with the graph. So this shows the percentage of each class label in the data set. So here total we have 15% of normal cases in the data set, generic of 15%, fuzzes of 15%, exploits of 15%, DOS of 15%, and the other attacks of their respective percent. So this shows the distribution of each class label of their percentage. So close this. Now we are supposed to pre-process it. So we need to click on this button, click on pre-process. So here the data set is pre-processed, shuffled, clean, and normalized. So this is these are the values after pre-processing the data set. And after pre-processing, the data set is split into two sets. One is training set and the other one is testing set. So here in the training set, 80% of the data set is assigned where we have 16,318 rows. And in the testing set, we have total 20%. I mean 20% of the remaining set is assigned to testing set where we have 4,080 rows, 80 data. So now we have done pre-processing. So what we're supposed to do is we need to run edge node 1 binary class. So click on that, run ensemble on binary class. So now we are supposed to click on run ensemble on binary class and run ensemble on multi-class models to train the ensemble binary class and also the multi-class. So click on that. So now binary class model will be trained. So this is a confusion matrix graph of the ensemble binary class, and this is the ROC AUC curve graph. Here on x-axis we have false positive rate and on y-axis we have true positive rate. Close this. And these are the metrics, that is accuracy, precision, recall, and FN score are used to evaluate the ensemble binary class model, and these are the scores of it. Now let's train the multi-class one. Click on that. Run ensemble on multi-class. So here the multi-class model has also been trained. So this is the ensemble multi-class confusion matrix and this is the ROC AUC curve graph. And here are its scores. Now we are supposed to click on run edge node 1 on binary classes to train the first edge node on the part of the binary data set. So click on run edge node 1 on binary data set, binary class. So here you can observe that node local model has been generated its weights and that are stored in the blockchain. So local binary class model has generated weights and that weights are stored in the blockchain. Now we are supposed to run edge node 1 multi-class. So by doing this, the first edge node will be trained on the multi-class part of the multi-class dataset. So click on that. So here we are supposed to specify the number of days. So by specifying that many days, the model weights will be stored in the blockchain. Suppose if we specify 5, here multi-class weights, it will be stored in the blockchain for 5 days. So click on OK. Now 5 days, the data set, I mean weights will be stored in the blockchain. So here all the weights of the multi-class and binary class are stored in the blockchain and these are the details of where that details are stored. So this is the transaction hash and this is the block number where multi-class and binary class weights are stored. And this is from address, this is to address, and this is the cumulative gas used, and this is the contract address. And that's all. Now we are supposed to click on run edge node to binary class. So to train the second edge node on the remaining binary data set. So click on that. Here you can observe that model training is completed and that local binary class edge 2 weights are stored in the blockchain. Now click on run edge node 2 on multi-classes. So here we will be training the model on the remaining part of the multi-class dataset. And here, similar to the edge node 1, here also we are supposed to specify the days. So let's specify same days. Click on OK. So minimize this. Let's get back to this again. So here, these are the details where the edge node 2 details are stored in the blockchain. So they are stored in the block number 6 in the blockchain. And these are the details. And these local model weights are stored in the blockchain. Now let's see this. So here, this is the node where this is the client one. And here we have binary class weights. This is the multi-class weights. This is of edge node 1. So these are all of edge node 1. And this is the hash code of edge node 1 where this weights are securely stored and this is the reward, this is the penalty, and this is the expiry date. That means this weights will be expired on this day. Similarly, the model update date, when the model has been updated. Similarly, here we have for the edge node 2. So these are the details for the edge node 2, and this is the hash code for edge 2, where the blockchain has stored the edge 2's model weights. So close this. So now we are supposed to click on aggregate and run global binary federated learning model, that is FL model. So click on that. So this will collect the global binary model from the blockchain and apply it to the test data. So this is the confusion matrix, and this is the ROC AUC curve graph of the aggregated global model of binary class. So close this, and these are the metrics. So here we can see the prediction accuracy. And now we are supposed to do the same for multi-class also. So click on aggregate and run global multi-class FL model. So click on that. So this will collect the multi-class model from the blockchain and apply it to the test data. That is test data. So this is the confusion matrix, and this is the ROC AUC curve graph, and here are its scores. So now let us compare all the models. So click on comparison graph. So this is a comparison graph. Here on x-axis we have all the models that are trained, and on y-axis we have the scores. Here each color represent different metrics scores. Blue color represent accuracy, orange color represent FN score, green color represent precision, and red color represent recall. So through this graph you can compare how well the models are performing in this project. So now close this. Now let's do the prediction. So click on predict attack on test data. We're supposed to upload this file. Select it, click on open. And here we got the predictions from the global federated model. So here we got the prediction. So for the first case, here we got the predictions that warm. That means there is an attack, and that attack type is warm. And for this case, here we got the prediction as DOS. And for the third case, we have the prediction as DOS. DOS is an attack type. So for this case, here we got the prediction as fuzzers, which means it is an fuzzers attack. So for this case, here we got the prediction as DOS. Similarly, for this case, we got prediction as fuzzers. And for this case, we got prediction as DOS. And similarly, for this case, for this test case that we have uploaded, here we got the prediction as shell code. And for the next one, DOS, 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 and DOS. So here you can observe that exploits. That means for this case, we got the prediction as exploits. And for this case, we got the prediction as exploits. And for the last case, not last case, last second case, we got the prediction as fuzzers. And for the last case, we got the prediction as normal, which means there is no attack in the given data. So this is how you need to execute the project. So this is all about the project.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.